Yeah. So today, this is the third session, I believe, and this is going to be about sorting and searching. I think Trishank has already informed you guys to learn about what introductory problems, right? And he also has introduced like the basic data structures. So today we are going to be solving a few questions on searching and sorting. And yeah, let's begin, I guess. So yeah, so what exactly is searching, right? Now, there's obviously the most basic way, which is like linear search. And if you think about it, it's kind of costly, right? To find one element's position, you're going to have to go through everything. So there are different ways, and like that's the main gist of this session, like how you're going to do it. So it depends mainly on like why you would want to do it. So I think like if we start solving questions, you'll get a better idea. Yeah. So let's start with the first question. And if you guys have any doubts at any point, you can just speak up or like leave a message in the Google Meet itself. Yeah. Uh, yeah. Let's start with the first question. So you're given a list of 10 integers, and your task is calculate the number of distinct values in that list. Um, I mean, this is like the very basic question. So, yeah, I'll just give you guys a minute to think about it, and then you can put whatever ideas you have in the message, right? Yeah. Then I'll discuss like uh, yeah. Uh, and one more thing is there's also these constraints which you have to look at. So mainly, it's like when you have a O of n solution uh, for a time limit of 1 second, mostly you can do like 10 to the power 10 to the power 6 to 10 to the power 8 approximately operations, right? Uh, yeah. So this is like one thing which you'll have to think about. So when like the constraint is 2 into 10 to the power 5, it means you have some wiggle room. So like n log n solution might work. Well, if the display solution will most likely not work. Yeah. Yeah. Do any of you have any idea on how you'd solve this? Like, which data structure would you use to store these n elements when they give it to you? Okay, I think yeah. So, yeah, I think Shashank has told you that there's something called a set data structure, right? Data structure. Yeah, so what uh, it does here is it only allows for distinct integers. So just like the question wanted, you can only have like you can't have duplicates, right? So as we are taking in the integer x, we can just insert it into a set, and then we can like just output the size of the set, right? And the implementation of this is pretty simple as well. Uh, like I can go with the int n. I'll take in n. Now for I less than n. First, let me declare my set of n, which is s. Now, I can just like take an integer x, cn x, and s dot insert uh, x. Yeah, and finally, I should output the s dot size. Yeah, uh, this should work. Let's just test it out. Yeah, so you can see the output is two, like as it is. And let's just submit this. Okay, yeah, I had to save this now. Never mind, my bad. Um, yeah, and guys, if you do have any doubts, like, you can speak up, it's fine. Or you can just message. Yeah, yeah, storing numbers instead is like perfect, yeah. Mm, yeah, so just in hundreds. It's C5, okay, now, yeah, uh, okay, okay, consider that. Hmm. Yeah, yeah, so this is a very simple question. Okay, yeah, so this was a very simple question. And yeah, uh, let's go to the next question, I guess. The next question is apartments. Hmm. So there are n applicants and m free apartments. Your task is to distribute the apartments so that there are as many as possible. So as many applicants as possible will get an apartment. Fine. Each applicant has a desired apartment size, and they will accept any apartment whose size is close enough. So like I'll just explain the question, right? Okay, yeah. So it's like there are different apartment sizes, right? Uh, and they're not given in order and stuff. And there are some people, right? And those people will have some apartment size in their minds. Um, Now our task is to like allow these apartments such that most number of people will get an apartment, right? It's not like the person should get the most desirable apartment they want. We just want to fulfill that many people get an apartment. And the range for a person will be the desired x, like, yeah, from x minus k to x plus k, right? Is the range of apartments for one singular person. Um, yeah. So how would you guys approach this kind of equation? Yeah, you can think about it. Okay, I'll explain this test case as well, right? So it's like 4, 3, 5. Now here, 4 is n. N is the number of applicants. M is the number of like apartments, and what else is given? K, yeah, K is like the wiggle room for that person. So, firstly, they're given the apartments, no, applicants' desirable sizes, right? So, 60, 45, 80, and 60. And the apartment sizes are 30, 60, and 75. So, now you can see, let's say these are apartment sizes, so 30, right? Now, the wiggle room of the closest person to 30 is 45, and it's only 5. So the lowest apartment size which 45 takes is like 40, but 30 is lesser. So no one will ever take 30. For 60, uh, okay, yeah, there are two people with 60. So any one of them will just take it. And 75 will be taken by this person. Yeah. So that's why the answer is 2. Yeah. So now, yeah, what do you guys think? Like, how would yeah, you saw them and compare. That's right. So we have this thing called a two-pointer approach. I think most of you will know about it. That's fine. I mean, it's nothing much. So you have yeah, N, M, and K, right? I'll just use a long. So one more thing is you can see that K is 10 power 9, right? I mean, 10 power 9 will fit inside a normal 32-bit integer, but it's better to use a long integer just in case there's overflow. Then it should be totally fine. So I'll have a of n and b of m, right? And now I do a for loop and taken the applicant sizes and then the apartment sizes. Yeah. So now I've taken an apartment size and okay, wait, A is apartment. My bad. Yeah, yeah. Wait, the n integers desired apartment sizes. Okay, desired apartment size. Yeah, yeah. So this is the apartment sizes desired, and this is the actual apartment size. Right. Okay. Now, yeah. As Pranav told, first we can sort them with an inbuilt sort function, comma a plus n, and sort b comma b plus m. Yeah. So now we'll have sorted integers, right? So we converted this into 45, 60, 60, and 80. And here we have 30, 60, 75. So now the main idea here is, um, yeah, I'll just write it here. Uh, yeah, so the main idea here is, um, like you have one pointer at 80 and one pointer at 75, right? Because they're the largest elements. And now we'll check these two values if they're compatible or not. Right. So this is the desired apartment size. This is lesser than it, and we'll see if this is compatible. If yes, we will just allot that, and we'll go to the next one, which is 60 and 60. Right, and this also will get allotted, and next will be 60 and 30. This will not get allotted, so we'll remove this desired apartment, this person's choice. Right, and next we'll go to 45. Okay, yeah, 45 will get and again 45 won't be uh, like taken up because 30 is less than 40. Yeah. So to implement this, we'll have two pointers. Let's say p1 equal to n minus 1 and p2 equal to n minus 1. And we can use a while loop while p1 greater than equal to 0 and p2 is greater than equal to 0. So we're running a for loop and if wait, p1 is okay, yeah. Um, b of p1 is greater than or equal to uh, a of b of p2. Remember, b of p2 uh, is the yeah. If it's greater than no, if it's let's go lesser condition first. If it's less than p2 plus k, p1 plus k, my bad. Yeah, or b of p2 is greater than or equal to a of p1 minus k. Right. Yeah. So this should work. In this case, we just allot it and we'll also have a count. So we'll increase the count and we'll decrease P1 minus and P2 minus minus. Right. Now, else, if, uh, now in this case, it's not inside the range, right? So we have a range for every person. So if it's not inside, there are multiple conditions. Uh, yeah. So let's say condition one, which is the apartment size is actually like greater than P2, P1. Yeah, my bad. No, wait, it's a P2. Mm, applicants, yeah, desired apartment size. Yeah, fine. Yeah. So if the apartment size is greater than the desired apartment size plus K, that means we can't use the apartment ever again, right? So we'll decrement the P2. Yeah, I just write it out. So if B of P2 is greater than A of P1 plus K, we'll decrement P2, right? Because the logic behind this is now P1 has the greatest TSP, greatest like value, let's say, like greatest desire. So everyone less than P1 has a smaller one, right? So if P1 doesn't take it, that means P2 will not be taken by anyone else. So we just decrease it and compare the next one. Yeah. And the other condition would be else if V of P2 is less than P of P1 minus K. In this condition, it means that the apartment is very small compared to the desire. So we'll have to take a person whose desire is less. So we'll do P1 minus minus. And I think that should be it. And we'll output the count. Let's just see if it works. Right, yeah. Um, okay, right. Um, complex classes. Hmm. I'm getting zero. Okay, fine. Count to zero, V2, less than this. And there should be an and condition. And is greater than, yeah, I think that is the thing. Hmm. Okay, never mind. Hmm. P1, P2. Let's just output the sorted arrays, right? Yeah. Right. Hmm. Okay. Yeah. So the error was that we haven't taken our inputs properly. My bad, my bad. Yeah. Now it should work. Yeah. So it's two. Um. Let's just save this and submit it. I'll save it as apartments. Yeah. And now let's submit it. I mean, it's better to use a like more recent more recent compiler. Yeah, so you can see it was the correct answer. Yeah. Do you guys have any doubts? Um, Okay, that's fine. Yeah, let's move on to the next question. So this question, there are any children who want to go to a Ferris wheel, and your task is to find the gondola. Okay, I don't know how to pronounce that, but yeah, for each child, I think it's like a container, and each container may have two children in it, two or one. In addition, the total weight may not exceed X, and you know the weight of every child. Yeah, so yeah, I think this is a similar question. What do you guys think? Do you have any approach? And you can see they give us like the number of children, and yeah, they want us to find the like minimum number of containers to like take every child in it. And one more constraint is like the maximum weight which one container can hold. It's always greater than the weight of one child. Right. So I'll just discuss the test case. So it's like four children and the maximum weight is 10, and 7, 2, 3, 9 are the weight of the children. So here you can see that 7 plus 2 is 9. So this can be one person. So 1 and 2 in one. 3 plus 9 won't happen. So 3 and one more, and fourth child in one more. So this is like a total of 3. But this might not be the optimal way to do it. Right. What do you guys think? How will you do it? I'll give you like 1 minute to think about it. Think along the lines of sorting the values of the children. Um, yeah. Uh, so you guys have any ideas? Yeah, familiar. Right. Once more. So the main idea behind this one is we'll have 2, 3, 7, 9, right? So now you can have one pointer at 2, one pointer at 9, and you can like add it up, right? So 2 plus 9 is what, 11, but it's greater than 10. So we know that the largest value needs 1. So I'll put 9 in one separate thing. And now the pointers are 7 and 2. Right, 7 plus 2 is 9, less than 10. So 2 and 7 in one more thing. And now both the pointers are at 3, so 3 will have to go into 1. Right. So now the answer would be 3. Yeah, I think the implementation is almost the same as previous. Let's do it. First, we only need an integer, and take the integer, and okay, we need an integer and the like maximum limit, and comma x, and x in p n in n p e of I. Yeah. So now you're taking in, and now we can have to sort it. P comma p plus n. After sorting, let's have a pointer 1 as 0, pointer 2 at n minus 1. Right? Yeah. Um. So, wait, one minute. So while p1 is less than p2, yeah, uh, p of p1 plus p of p2 are greater than x, yeah, greater than x. We are removing one and count plus. Yeah, and have a variable for count, like for counting the number. Now, else if this is okay with this lesser. Yeah, we're increasing count. P1 minus minus. Yeah, else we'll have this some. I think equal to also would work here. Yeah, equal to should work. Else if this is lesser, it is greater than x. That means we're doing P2 minus minus count plus plus. Yeah. So this is actually not completely right yet. The thing is, there are cases in which it, this while loop will end at P1 equal to P2, right? So if P1 equal to P2, we'll just do a contrast class. Yeah. Hmm. Yeah, that should work. Now I'll just output the count. Let's see if it works. Wait, what? You got a 5. Hmm. Do you know less P1 plus plus? My bad. Yeah, yeah, 3. That's right, I guess. Let's just make a submission and do it. It's, yeah. Um, we are submitted. Okay. Yeah. Hmm. Yeah. Yeah, that's right. Uh, do you guys have any doubts? Yeah, and Taylor is in know. And let's go to the next question. Um, the next question is concert tickets. Wait, just confirming you guys understood, right? I don't want to just like go to the next question. It's fine. So here there are n concert tickets available, each with a certain price. M customers arrive one after another. Each customer announces the maximum price they are willing to pay for a ticket, and after this, they get the ticket at the nearest possible price, such that it doesn't exceed. Yeah. Do we need to do this question? This is very like this is easier than the apartments question, I think. Right? Yeah. So, what do you guys think? How would you solve this? You can take a minute, think about it. Here are the constraints. Okay, here the price okay, and after this ticket can be person. Okay, what are we outputting here? For each customer, will output. Okay, so here this question is slightly different. Hmm. We're not just outputting the maximum like number of customers who can get a ticket. We're actually outputting the cost which each customer will pay. Right. Hmm. So first we get the ticket values which are like 53785, and then there are three customers, and each customer announces the maximum price they're willing to pay, the nearest possible price. Okay, yeah, come on, fine. Um, yeah. So what kind of a data structure do you think we can use over here? The, this is actually very different. The thing is, they've told us that they come one after another, right? So we will have to sell it to them. We can't sort and do it. I mean, we can, but that wouldn't be optimal, right? Because we can easily do this with the help of a data structure. What do you guys think? How would you try to do this? So I'll just explain. 5 and 3 are given to us. And now we have these tickets with us: 5, 3, 7, 8, 5, and 4, 8, 3. Right. So for 4, we'll need to check if there's a ticket which is less than or equal to 4. Right. There is one, 3. So we just output 3. Now for 8, we check if there's a ticket less than or equal to 8, which is there. This is 8 itself. So 8. And again for 3, we could have given this 3, but we only use this for 4. So we'll output -1. Yeah. Uh, what kind of data structure do you think we'll be using? Hmm. Um, yeah, you're right. We will be using a multiset. So the idea behind this is this is a function called a lower bound. Wait, is it lower bound or upper bound? I'm not sure. Lower bound. Lower bound returns the iterator first element in the range first to last. Not less than. Okay, so it's the upper bound. Where to find the upper bound? I believe. So lower bound for element 30 index 2. Yeah, wait. Let's just do it. Yeah, I think it's lower bound itself. Do you think it's lower bound, upper bound? Yeah, let's just implement it. It's fine. Um, yeah, here we taken n and m, and we taken n, and let's have a height and the tickets. No heights. One second. Yeah, prices and maximum prices. Let's, okay. Price lesson. Okay, we don't even need the. Yes, it's a multi-set uh, integers. Mhm. Yeah, we'll just keep it long. Okay. Um, so let's take in the number. Which I'll just comment this out. Yeah, I'm taken h and m dot insert h. Yeah. Now I've done one more loop for the people's maximum values. Now, check if, no, okay, I think it's lower bound itself. Um, value lower than given. Yeah, it's lower one. So, if m dot lower bound, okay, we have to take in the uh, maximum ticket price is taken as t. If it's not equal to, let's just take with the corner case. And this output uh, -1. Right. Else, uh, And what erase, I guess. Erase and that lower. Okay, first let's all good. Yeah, so this returns an iterator, and for the value of an iterator, you can use the star. Erase and not lower bound. Keep. Yeah, this should work. Let's run it. Okay, control the information. Okay, let's use this M1. Uh, yeah, five. Wait, what? 538. 583. Oh, mhm. Hmm. Is it right? Okay, yeah. So you see, lower bound returns the value greater than or equal to. So it's actually upper bound. My bad. Sure. Wait, what? Hmm. Mm, no, it's not present, right? Hmm. No, it should be lower bound itself. CMP insert and okay. Let's just print out all values in M. Let's see where they're going wrong. Hmm. We have a 3, 5, 5, 7, 8, and a 5. Wait, okay, I think, huh? Just to, yeah. Okay, 5 is from them. Um, let's output, yeah, let's, hmm, I'm going to want to, okay, this is lower bonuses. Yeah, I don't know why I'm working. Let's see. Okay, 3 low bonus, 4, wait. So is it an upper bound? I'm not sure. Hmm. Because there are three. Yeah. Okay. I don't know why it's not working. Let's check it out. Okay. The lower bound statement. It's the output. Yes. Okay, yeah. So for 4 is giving 5, for 8 is giving 8, and 3 is giving 3. For 4, why is it giving 5? Um, okay. Okay, because it's begin. Right? No, that doesn't make sense. So the upper bound, I think it is upper bound. Not sure. But actually, I'm not sure why this isn't working. It should be lower bound itself. Wait, do you guys have any idea why it isn't working? This is the code. Should be working. Mm, mm, it's fine, guys. Let's just come back to this question next. Let's go on forward. Yeah, restaurant customers. Okay. You're given the arrival and leaving times of when customers in the restaurant. What is the maximum number of customers in the restaurant at any time? Yeah. So you're given the arrival time and ending time, leaving time. Okay. Okay. So what do you guys think? How would you approach this? And you have to work with the maximum number of customers. Yeah. So I'll just explain this one. This AMV listing. Yeah. 5 and 8, 2 and 4, 3 and 9, right? We'll just make a timeline. Right. So at 1 there are 0 people, at 2 there's 1 person coming in, 3, 1, 2 people, 4, uh, second person goes out and only the third person is left. 5 there are 2 people, 6, 2, 7, 2, 8, 1, 9, 1. Yeah, so if we have an array like this, we can just output the maximum of that array. But one thing you should keep in mind is the range of this B and A is 10 per 9. So we can't do 10 per 9 operations in 1 second. So yeah, we'll have to do one slight optimization, which is taking the value of these bounds only. We shouldn't consider every value. So that would be like it would be like this. 2, 3, 4, 5, 8, and 9. Right. At 2, 1 person comes in. At 3, 1 person comes in. So it will become 2. At 4, 1 leaves. At 5, 1 comes in. At 8, 1 leaves. At 9, 1 leaves. Yeah. So it'll reduce to this array. We get this. And the size of this would be 2 times n, right? So that's doable in overpen. Yeah. So let's just implement that. Hmm. Actually, yeah. That should work. And let's take an end, and that is yeah, and BFM. Wait, actually, I think it's better to use a vector of pairs. No, let's have a vector. Yeah, I think it's better to have a vector of pairs. Uh, and it's near the yeah, no, and then loop, and yeah, A comma B, and then put A, and yeah, B also. Okay, so yeah, I think I would read a push back, and this makes it a pair, and one, and read a push back, B comma minus one, yeah, I think it should work, and now I need to read sorry, read a begin, my bad, mm, read a, and yeah, and then yeah, have a in max. What I doesn't read out says plus plus. Uh, I have current sum is zero, and sum plus equal to p of I dot second, right, and mx equal to max mx comma sum, yeah, and I'll output my max. That should work. Wait, isn't typing again before? So we have one extra bracket. Yeah, that should work. Pairs. Yeah, so we got the answer too. Let's try and submit this. Restaurant customers. Mm, and yeah, that's right. Okay, we have one warning saying we can't compare I and we can say, oh, that's fine. It will automatically change it to an integer. Yeah. So did you guys have any doubts? Okay, nice. Let's go on to the next question, which is movie festivals. So here, in a movie, there'll be annual movies. Okay. In a movie festival, there are movies, and you know the starting time and ending time. What's the maximum number of movies you can entirely watch? Yeah. What do you guys think? How would you do something like this? So, the so for this question, the like range is given to you, right? Some ranges might be here, some ranges might be there, some might be like very big. So the optimal way to choose would be to choose this and this, and if there's something this here, this, and that. So you could get three. If you chose these two, you only get two. Something like that, right? How do you guys do it? Yeah, I'll just explain the this case. So there are three movies: 3 to 5, 4 to 9, and 5 to 8. Yeah. So we can watch a movie from 3 to 5 and 5 to 8, and the answer will be two. Right? Yeah. Mm. Yeah, that would be the answer too. What do you guys think? How would you do it? One interesting observation which you could do here is, um, it doesn't really matter what I choose later, right? Like before. Let's say, um, 5, like 3 to 5, right? If there was one more movie from 1 to 2, and the other two numbers are 4, 9, and let's say 1 to, okay, no need 5. Let's say 1 to, okay, this is, let's change this to, this to 3. And if it is like 1 and 4, right? If it's 3 and 5 and 1 and 4, it doesn't really matter if I swap 1 and 4 with 3 and 5, because the answer would still be the same, 2. I'll watch either one of these and then 5 and 8. So the interesting observation is, I'll want to watch the movies which get over as soon as possible and which I can watch. Right. Um. So, yeah, I this yeah, I think that should work. So the idea behind it is, like, I think we need a vector of best. Hmm. Yeah. So the idea behind it is, we are greedily going to choose the movie which gets over as soon as possible, right? So that we can like have more time for watching the next movie. Like, we don't need to eliminate movies which can be watched later, right? So we'll remove all the movies which are like very long and stuff. Yeah. Uh, Two integers a and b. So long a and b. I'll input a and b. Now I'll read or push back uh, a pair of b and a, right? Because we need to sort based on uh, our base. Yeah. Now I have an integer of from essentially 0. Then we do it from 0 to, okay, I just sort it. Sort with a begin. V dot end. Yeah. And now I need to look at the last value. Yeah. So I have a movie time, movies max time. Yeah. I'll initially keep it at 0, right? So now if we apply dot second SCCOMP is greater than movie max time, and okay, we are first is greater. Man, because equal to what equal to work? Yes, equal to work. We are first. Yeah, so we just take the movie, we watch it, increase our count, and make a movie max time. Let's verify that. Second. Yeah, this should work. And then the output the count. So this is input and then it wait what? Three. Okay. Let's think about it. Initially it's zero. Okay, first my bad. This should be second. Second. And this should be first. Because we are switching around, right? Yeah. Yeah, that works. Let's okay, let's make a submission. Yeah. Submit. I'll choose a file. Press submit. Um, yeah, it works. Okay. Yes. Do you have any doubts? Do ask. And one more feature of CSS is you can look at the problem statements, like the test cases, so that you can input and like run it yourself. Hmm. It's 11:34. Okay. I think we can. Let's try to squeeze in two more problems if we can. Yeah. The next question: sum of two values. Right. So you're given an array of integers, means your task is to find out two values whose sum is x. Okay, and you'll have to give their indices, I think, 8, 7, and 1. Yeah, you'll have to output the indices. What do you guys think? How would you guys do it? Yeah, that's right. You would use a map to store the value and index. That's right. So, okay, should I do it? Yeah, just do it quickly, okay? Um, So n and the target x, I will input x2, and then I will run a loop. Uh, to, yeah, and then I'll yeah, just take them out. Yeah, the thing is, you can't use an array to like directly hash it here because you can see that the constraint is too big, and it's not. I'll read the value of a, and then I will map it equal to I. Right. Yeah. Yeah, I think I should also store the value. Then let's make it capital A. Uh, here, and capital A. Yeah. So now we can run a loop from 0 to n. It can have Wait, is if no solutions to net possible. So we should have a flag. Flag is zero. Wait, yeah. So now if um, x minus a of I will give like the difference, right? So the next value m of this is not equal to okay. I think we should make it I plus one because default value of anything will be zero. It's better to have values from one onwards. If it's not equal to I, yeah, or it's not equal to zero to zero, and it's not equal to I. Yeah, so we should check two cases, and it's not equal to I plus one. Remember, I plus one, we output I plus one, and term of x minus a of I. And we also make the flag is equal to one. Now we break it. Yeah. If not f, we output impossible. Yes, I think it should work. Let's see. Hmm. It's two and four. Yeah, it's mostly right. Let's run it once. Name it. some- Yeah. Oh, great. Okay. Yes, I think I should work. Let's see. Yeah, that works. Nice. Uh, do any of you have doubts? Okay. Uh, yeah, cool. Okay. Okay, yeah, let's just do this last question. It won't be that long, guys. Just 10 more minutes max. Right. Given an array of n integers, it asks you to find the maximum sum of values in a continuous subarray, non-empty subarray. Wait, yeah. What do you guys think? How would you guys do this? This is, I don't know why this question is here. It's not exactly sorting and searching, but this one algorithm, which I don't know. Yeah, let's see. What do you guys think? How would you try to solve this? I'll just explain the test case once. So it's like this, like the eight integers minus 1, 3, minus 2, 5, 3, minus 5, 2, and 2. And the answer is 9. So there's exists a continuous subarray, so that the answer is 9. No, the answer of this subarray is like 2. So we'll take it in 3, 2, 5, 3. I think this would be yeah, 1, 6, 9. Yeah, I think this subvariant of like 3 minus 2, 5, and 3 sums up to 9. I think that's, yeah. So we just need the answer, right? We need the maximum value. Yes. So how would you guys uh, approach it? I'll give you guys a minute. Think about it. Right? I don't know why exactly this question is here. Actually, it's fine. I'll just tell you guys the answer. There's actually a pretty famous algorithm. I think it's called. Wait, it's fine. I'll just tell you how it works. So, the main idea behind this is we'll have a sum, right? No, and see, the sum until here is minus 1. It's negative. So, is there any use of taking this minus 1 forward to any of the subarrays forward? It's actually no, because it would not maximize the subarray sum. It would actually like decrease it. No, I see this 3. Okay, fine. 3 is greater. Uh, 3 is greater than 0. I'll take it. Now I'll see 3 minus 2, right? This is, sum is 1. So if I can like make 1 the prefix of the next subarray and the answer is positive, then it works. Yeah. So I take it forward. And yeah, 5. Yeah, 5 plus 1, great, 6. 6 plus 3, 9. Now I've got 9 minus 5. 9 minus 5 is still 4. Yeah, I'll take it. 4 and 2, which is 6. 6 and 8. Yeah. So maximum is 9. That works. I'll just write the code for this pretty fast. Yes. So we only need one n. I'll input the n, and now I'll have an integer x of n. Yeah, and here also negative integers are possible, right? Obviously, I have taken x of I. Yeah. Now I'll have a long integer max. So initially, you can see that we can't have non-empty subarrays. Yeah. So let's just take like a minimum value, right? In mind, it would be like minus 110 or something. Actually, yeah, that would work. Yeah. Uh, mi equal to min. Uh, mi is less than no, x of I is less than mi. Mi equal to x of I. Yeah. So I got the minimum value. Let's say the maximum sum is the minimum value, right? That one sum, right? Yeah. Now I run a loop for each element and I keep this sum equal to MIX, sum equal to 0. Yeah. So first, if uh, sum is less than 0, I make sum equal to 0, and then I do sum equal to sum plus x of I. Right. Yeah. So I've added this. Now if uh, yeah, this mx equal to max of mx comma sum. Yeah, this should work mostly. Yeah. Now I need output that. I'll just take this in. Hmm. Yeah, the output is 9. Yeah, that should work, guys. Let's try. Max sub sum. Yeah, sorted. Choose max sum. Yeah, it's called. I keep forgetting the guy's name, the algorithm. Yeah, it's that. It's exactly right. Uh, that works. Cool. Yeah. Okay. Shall we go for one more question, guys? I mean, It's it's already been an hour. I think that's enough for today. And yeah, before leaving, can all of you just like write your names? They need a attendance too. So yeah, just write your names in chat. Right. No, that's fine. I'll just take a screenshot. Sure. Uh, so yeah, cool. Yeah. So that's pretty much it. And before ending, there are many more questions in this. If you would, if you guys would like to have one more session on this, we can. Like, otherwise, we'll move on to the next topic for the next week. And guys, do practice all of these. If you can't, contact any of us and like tell us if you have any doubts or anything, or just try to solve it yourself. Or like, there's also like multiple cses problem set solutions, right? You can look at any of them. Yeah, that's fine. So that's pretty much it for this session. Uh, we'll decide and tell you whether we'll have one more sorting and searching session, or the next week will be DP. Right. Um, yeah, that's it, guys. You guys can leave.